So good evening, this is 11:15 p.m. So I'm going to be replying to my fellow quantized colleague, a physicist like me. He said I should explain the double splitting experiment. Please stay tuned. Physics. So I'm going to be explaining the double splitting experiment. The double splitting experiment is just trying to tell you that light and matter has two basic properties. It can exhibit two basic properties. We have the wave-like property and the particle-like properties. This brings us to a part of quantum mechanics that we know as the wave-particle duality. Now, wave-particle duality. Now, the origin is in quantum mechanics. So in quantum mechanics, they're trying to let you know that light and matter exhibit two properties. Light and matter exhibit two properties. The wave-like property and the particle-like You know what's strange? This is very strange. You know why? Because in classical physics, if you do this experiment, there's something you will not see. This experiment is very awful and weird in sciences, especially to explain quantum mechanics, because in this experiment, it is assumed that photons, when being observed or when being experimented, change their properties. But that's not true, because if you are telling me matter is supposed to exhibit a particular properties, whether they are measured or not, their quantity and changes are not supposed to be altered. So when they are not being measured, when photon or light is not being measured, it has another property. Let me give you an example. Let's just say this is a source of light. Now you want to pass this source of light through two parallel slits. Let's say this is the first parallel slit, this is the second parallel slit. Let's say they are equal, right? And there is a passage, there's a little passage that allows light to pass through it. Then this is the back mirror. This mirror is used to observe what happens when light, let's just say a beam of light strikes this, or several beams of light strikes this slit. Strike it. What happens? Instead of getting like classical mechanics, you're supposed to get a reflection of light here in the mirror, stating that the light passed through this slit and hit here. Instead, you are getting one bright light showing here and another dark light showing here. Have you seen what's happening here? So scientists began to wonder, why would we get dark light and bright light when we are projecting only one, and we are supposed to get this in classical mechanics? Okay, let us take an instrument, a detector. Let's take the detector at the back of here. This is the detector. Now this detector, let's use it to measure the amount of bright light and dark light that is produced here. And when this detector is introduced here, the photons that comes from the source gets here, interferes, and the interference vanishes and gives you only one light here. Scientist is confused. There's no logical explanation to it. Is this a magic? Why would it deviate from the normal when a detector was introduced? Now let me tell you what happened here. What happened here was simply interference of light. When even if it's a single photon that comes from this source, the double slits that are parallel, passes through the part where light can pass through it, and gets to the mirror part where the observer can see, there was an interference, and that first interference gave you the bright light. The second interference, where you see the dark light, is when the both particles, the particle of light, came together to cancel each other. That means at this point, they came together to cancel each other. And this is strange. Light coming from here, it gets to a point, it gives you two lights, one bright and one dark. Then we are trying to now find, as if that's not enough, as if that's not mysterious enough, we are now trying to find out what happened. I bring a detector as a scientist to measure the amount of beams, the amount of rays that caused this bright light or this dark light. And when I get here, the property of the photon from the rays of light changes its characteristics and takes us from quantum mechanics to classical mechanics. So that's my explanation. Thank you so much, my fellow contest colleague. Let me move to the next question.